My work revolves around a class of materials which are called organic semiconductors. So they're basically plastics, and people are used to plastics being used for insulating electrical wires, but actually they can be made to conduct electricity and act as semiconductors. So the real attraction for coming to Melbourne and to Monash is not only the support offered by Monash University and VESKI, but also the national infrastructure which is close by. So there is the Australian synchrotron right across the road, which is a world-class facility and a great asset for Australian science, and there's also the Melbourne Centre for Nanofabrication. So they are sort of two key facilities which play a key role in my research. So the synchrotron is great in that it allows you to probe the structure of materials in a way which is not so easy to do with other techniques. One of the big applications is for flexible solar cells. So solar cells, which people are familiar with, are usually made from silicon. They're brittle and they're quite expensive still at the moment. So this is a flexible solar cell which is being developed by colleagues at CSIRO here in Melbourne, and this exemplifies what's exciting about this area in that you can make these semiconductor devices by printing on flexible substrates, and this is printed in a similar way to you might print a newspaper, which means that it can be printed with high throughput and low cost, and we can have solar panels everywhere. So that's one of our main goals and dreams.
Well, it's wonderful to have someone like Chris here because he has a lot of skills that complement the areas that we currently work in. He works in areas that have important impacts into the community, such as in energy or displays. He also has a lot of collaborations that he brings with him, including some across at CSIRO in the Flexible Electronics group. So we're really involved with those people, but Chris will add an extra dimension to that.
VESKI is a really important program for Monash, and we have a long-standing relationship, and it's been really critical for us in bringing fantastic talent back to Melbourne. And as you know, universities, it's a war for talent across the world, and we have to compete with the very best universities all over the globe. And VESKI just allows us to be that little bit more competitive to bring the best and brightest back to Australia.
After my PhD at the University of Newcastle, I moved to the Cavendish Laboratory, which has one of the world's best organic electronics research groups. It's headed by Professor Sir Richard Friend, who was the inventor of another type of plastic device, the plastic light-emitting diode, in collaboration with one of the VESKI fellows, Andrew Holmes.
Chris McNeill's a great catch for Australia because he's working in this area of polymer and plastic solar cells, which is so important for renewable energy. There's an indirect VESKI investment in this already. What we're doing now couldn't have been done without VESKI support originally, and that's where I first had contact with Chris's research group in the University of Newcastle. So it's almost seeing the story turn full circle, and the completion is to see him return to an appointment here in Victoria.
The additional support which VESKI provides, and also sort of an extended family for which to sort of collaborate and meet like-minded scientists across broad fields, because coming from Cambridge there's sort of the collegiate system where you can engage with people from broad disciplines, and that's something which is generally lacking in Australia, so to have that sort of replicated in some ways in the VESKI family is much appreciated.